Did it start recording? It didn't explicitly tell me. I think it usually does.
Yes, I see it.
Yes, it is recording.
Perfect. Okay, great. Let's get started. So starting at the basics, we're going to do a quick intro to JSON. JSON is JavaScript object notation. And what that really means is it's a dictionary of attribute value pairs. So a good question is, why do I need to know JSON, particularly for today and in life? And for us today, our database file is written in JSON, so it's a JSON file. In general, this is actually pretty common for you to get back your REST API calls with JSON, and knowing how to read that, how to parse that, how it relates to other objects in whatever language you are working in is a really valuable skill to have. So we're hoping that doing this little intro to it will help you visualize what JSON is, what it looks like in a different code, and how to communicate between those when you're accepting network requests. So an important question is, what is in our database? And in this case, we have a list of members, we have a list of resources, we have a list of quotes, and we have the Women Who Code Cincinnati contact information. So that's a lot to go over. So we're really going to deep dive into how we take one of these members, build a JSON object of that, and what that looks like in a list. And then we can do the same exercise for resources and quotes on your own time. So attribute value pair. So what does that mean? An attribute value pair is just an attribute name that maps to a value. And when you look at actual JSON code, it looks a lot like this. So your attribute name is in quotes. In general, JSON styling is using the underscores, which I think is called snake case, to a value. Values can be strings, they can be Booleans, they can be numbers, or they can be other dictionaries or lists. So next, what's a dictionary? And so a really simple definition of a dictionary is just a collection of those attributes or attribute value pairs. So having just one attribute mapped to one value and putting that in the curly braces, that is what a very, very simple dictionary will look like. In reality, those are going to grow a lot bigger, and we'll see what that looks like. So if we're talking about members, we can talk about the kind of attributes that members have and build that into our JSON object. So you all have a name. You're all in a specific location. You all have beautiful faces. You have hobbies. You have a skill set. And you have, most of you have social media links where you can be reached, whether that might be LinkedIn, GitHub, Twitter, you name it. So now we want to describe all of these objects in terms of types that JSON can accept. So if we think about your name, a name is just a string, is just a set of letters. And so that is best described as a string. Similarly, in this particular case, we don't want to put in there's lots of different ways to describe a location. You could use an address, you could use your GPS coordinates. For us, using a string is good enough. Just saying Cincinnati, Ohio as one string works. When we talk about hobbies, my hobbies are writing code, mentoring other people, petting dogs. I really like dogs. That becomes a list of strings. And so we see that hobbies and skill sets can be described by a list of strings. So now we have two more complicated things. Your face is most likely described by a picture, right? That's how I can visualize who you are and what you look like. When you're talking about network request, a whole image is not a good choice. It's really large. It's not human readable. And so a better way to send, to describe an image is to send a URL. And then we still send that URL as a string. Finally, we can describe social media links in a couple of different ways. For example, we might want to do it as a list of strings. But what if in my project, I want to specifically pick out one? I want to share your LinkedIn, and I want to share that with a LinkedIn icon. If I have a list of strings, I can definitely do some filtering, search for the string that contains the word LinkedIn, and I could map that directly. But what happens if I want to change my data structure in the future so that maybe I don't need your full LinkedIn URL, I only need your LinkedIn username. So only the thing that goes after linkedin.com/in Sierra O'Brien in my case. And so it makes more sense to make this actually into a links dictionary where I can directly map, this is my Twitter attribute, and this is my Twitter handle name. This is my LinkedIn attribute, and this is my LinkedIn username. Or in our case, we'll actually use the full links. So what does this look like when we're talking? So now we kind of have this view of what a member is. We have names, image, URL, a location, a list of hobbies, a list of texts, and your links object. So then when we look at that within JSON, it becomes this kind of structure. So first, notice those outward curly braces, just like I showed in the first dictionary, which was just that single attribute value pair. That whole thing is wrapped in outside curly braces. Then I start seeing these attribute value pairs. So I have my name, and it's mapped to, in this case, a string, your name. Image URL is mapped not to a link to your phone, to a link where your URL might be. One really good place to get URLs is if you open your LinkedIn photo in a new window and just pull that URL. That's where I got my URL for my test object. And then we can look at some of these lists. So a list in JSON is a lot like a list in JavaScript, given the name JavaScript object notation. And so you see those square braces around my list of texts and around my list of hobbies. And then inside those, it's just string, comma, string, comma, string, comma. And then the final without a comma. And finally, we can look at our links object. Going back to how this whole dictionary is wrapped inside curly braces, now links is its own dictionary. It's a custom dictionary that goes inside my my member dictionary. And so then I have, again, a set of attribute value pairs. In this case, I have website, a link to your website, Twitter, a link to your Twitter, and so on. And so as we do this, we'll keep building these same kind of structures up. So this is a single member. I said that at the end of the day, we're going to have a whole list of members. And so it will look a lot like these hobbies, where it's in quotes or in square braces. So if I want more than one member, I'll add a comma and I'll put another member below it. And then those two members will be wrapped inside of square braces to denote that it's a list. So what can go inside of these? You have numbers, booleans, arrays, which are really lists. There's no differentiating between a list and an array like there is in some languages. You can make it a null, although in the case of REST APIs, you don't have to explicitly put the null in there. You can just take out that attribute altogether. So for example, I, as a person, do not have my own personal meetup. I should, it would be awesome, but I don't. So I can just take out that whole row and delete that last comma so that it just doesn't exist. And then I, as a front end or mobile developer, know that that was actually a null, and so I just don't have to deal with it. And then finally, the last thing that you can do is other dictionaries or other objects. So I mentioned that we're going to be using a REST API. So how does this file of JSON become a REST API? We will be using a MyJSON server. So it's a free online service for any public repository that has a file named json.db in the first level. And so what that does is it takes that JSON file from GitHub and it instantly returns, it makes it into a fake REST API. So in this example, they have some repo and they have some posts, a list of posts that have an ID and a title. And then when you make that network call, it will go through the levels of the JSON and return your JSON object. And so their call is users/repo. In our case, our user is Women Who Code Cincinnati /repo. It will be database, I think. You'll have to double check. Slash will have /members because members is a top level object. We'll have links or contact information, resources, and quotes. And so we'll have 4 endpoints. So that kind of covers what we need to learn about JSON. There's examples for each of the different data structures inside the repository that we'll go into in a little bit more detail when we switch into our breakout groups. Are there any questions about this now before we switch gears and jump over to Gatsby? Dun, 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 dun. All right, Alex, take it away.
All right, let me go ahead and get set up here. One second. All right, let me share my screen. Goodness sakes, now I lost the thing to share my screen. Okay. All right, do y'all see my screen?
Not
No.
yet.
No? Oh,
You
goodness.
see your beautiful face.
Let's share screen. Ah, I didn't click share. All right, do you see my screen now?
Yes.
All right, yeah, okay. So my name is Alex and I'll be doing the introduction to Gatsby JS. The project, well, not the project, the slides are called Ghostly Gatsby because it's Halloween theme and there's a ghost on every slide. All right, so let's get going. So this is just an overview of a little bit of what we'll be covering today. So an introduction to Gatsby, and with that, we'll have to do an introduction to React, which is pivotal, and a small introduction to GraphQL. We'll also go over the project overview. And so what is Gatsby? Gatsby is an open source static site generator that has performance, scalability, and security built in. Gatsby is able to streamline the setup and configuration of your build. It can pull in data from your user interfaces, and also any and all of your sources that you would like to request that data from. So CMSs, databases, APIs, and it already has amazing performance and best practices built into the site right out of the box. It utilizes React for building the UI and GraphQL to provide a declarative development experience. So why we chose Gatsby for our front end project? It's more than a site generator, as you'll see, and working with the site through the use of React and GraphQL. So it's able to create interactive and content-rich user experiences. It's also the #1 fastest growing framework used by organizations of all sizes. You're able to use popular frameworks and tools, not just React and GraphQL. You're able to use different plugins that ship nicely with Gatsby. As well as easy to get started. So there were starters and themes that we could choose from to get a nice baseline quickly. And then the last one that I like is to think about it that there's so much open source that we're doing. So it's an open source framework that allows us to use open source tools while contributing to an open source project for an open source event. It's just so much open source. Okay, now we'll go through React in a quick time. So React is a JavaScript framework that's used for building user interfaces. It's component-based, which makes it very composable. So I guess in thinking about that, we can just think about this slide by itself. So the card could be its own component, like a container. And then the different building blocks within it are the title, which could be its own component, the text, as well as you could have a use case for making this image, this ghost image in the right corner, its own component if you needed to change it out. With React, it's unidirectional data flow, so data flows down from the parent to the child. There are different types of data. So state is anything, private data that's within the component that you want to keep track of. Props are what can be passed down from parent to child. There are also lifecycle methods that you can hook into to update your screen at different points, as well as the virtual DOM, which is a tool that React uses to check what needs to be updated when. And it can also be used for server-side rendering. So next we'll go through Okay, we'll go through, this is an example of how like Gatsby uses React to fetch data at runtime. So on the left side, we have a class component, which can be used to fetch data. So we're able to see at the top, we have this.setState, which is that internal state that I was talking about. We're able to set initial value for data. And below, we're using a lifecycle method because we know that after we make that data call, that network request, we need to update the screen. So component did mount allows us to reach out, get whatever we need, and then render it to screen once it's available. So we're doing that, and we're able, one thing to remember is that state is immutable, and there's only certain ways to, certain ways. In the class component, the only way to update state is to use this.setState. Okay, so below that, we're using a render function. So in class components, you have to use a render function to render what you have to screen. And we're looping through that data that we have and then using an example item component to display that data. So we're sending in props for that. So title, description, URL, and then that component is able to render that information to screen for us. One thing to remember when you are looping through information that's returned, that's set on state, really any array or any list that you're showing, you'll need to have a key if what's shown is also coming through from a component. Cool. So on the right side, we have a function component, which is just another type of component in React. Back in, I'd say, 2007 or before React 16.8, you would reach for a class component if you needed to use state within a component. But now with the use of React hooks, virtually it's dependent on what you feel more comfortable using. So you're able to use state through the use of useState, as well as update the component using useEffect. So here we're setting that initial state with useState for data, and then set data. In this instance is similar to this.setState because that's the only way that we'll be able to update that initial empty array. So we're going through fetching that data, and then below we can see that we're returning, doing the same thing, rendering that example item component. All right, moving on. So GraphQL, we'll do a really brief introduction on GraphQL. It's a query language that helps you to request exactly what you need. Within GraphQL, you define the type and the structure of your data so that when you make that request for it, you know what exactly is coming back. So unlike with REST, you may be getting things that are unneeded. With GraphQL, you're able to, I guess, make the call as robust as you need, or as simple as you need for within your query, within your application. In Gatsby, GraphQL is used at build time, and this is completely optional. I would say like you would use GraphQL within Gatsby for things that won't update often. So like static queries, page queries, anything that isn't going to be updated consistently. So here is graphical, the playground that ships with GraphQL. And here you're able to visualize your queries. So this is actually a screenshot of everything or every query that's available to be made within our project that we have. We have a site meta query, and this is just running through like what all would be returned on this query. Okay, so Gatsby, React, and GraphQL, putting it all together. So again, here's that site metadata that we have. This is actually listed in the config file within our project. And this is a static query. Static queries allow you to get the data into a file instead of using props to pass information around. So yes, you can see that we're using use static query. Our query, we're telling it what we want to, the information that we want. And then in our return statement, we are passing that information through as props. It'll go through to the header as well. That's the only place that it goes through here. Cool. So what we're actually working on, this is a GIF of the site as it stands right now. We have different pages for members, quotes, resources, and currently there's a pages for contacts. It's basically an oyster for you to go in and work on and contribute to. So here's our project structure. Let's start with this source directory. So within our source directory, we have another directory called components, and this is what holds all of those individual components. These are the building blocks of the pages. And the pages are those, think of them, yeah, the pages like they're huge containers basically. And really anything that you put in that pages directory, you can access that page by going to / whatever that file name is. So if you wanted to add in a new page, you would do make the file name, make your component, and then to access it, you would go to / whatever that file is called. We have a utils folder. This has a helper function for fetching data. It's a fetch request that returns an object with success and your data if it's successful, or returns false with the error message if that fetch request was not successful. As well, we have some Gatsby specific files. So here's this Gatsby config. This is where that site metadata is listed. These are your configuration options for your Gatsby environment. You can also list your plugins in there. So everything that's available within or from Gatsby is basically sitting within that config file. We also have a Gatsby node file. This is for data fetching at build time. So some things to remember, nothing is set in stone, and this is a working repository, so things can change and they should change. So even if something is built out currently, so coming from this starter, feel free, if like you're more comfortable with GraphQL or with React, to change it and make it how you see would make, or how you feel would make the project run more efficient. Just remember, we're all learning together and we're contributing to open source through this event. All right, that's it for me.
Do you guys have any questions before we move to the next topic? Okay. After this, we'll have time to go a little bit deeper into some of these topics. So, let me get all my links set up so I can see everything. Okay, so our final repo for today is going to be a mobile app written in Flutter. And hopefully I can convince you of that in about 15 minutes. So I didn't introduce myself before, but a little bit about my background, so you know like how I come at this is I'm a senior Android developer in Cincinnati. So I know a lot about mobile, but I do not know as much about mobile as or as much about Flutter as I do about Android. But we'll get through this together, which accurately begs the question, why are we doing this in Flutter if I am not an expert in Flutter and I am an expert in a different mobile technology? So first and foremost, I want this to run on everyone's phone. We'll talk a little bit about what Flutter is, but it can be built on every operating system. And so we didn't have the limitation of like iOS and needing a Mac. And it can run on every kind of mobile operating system. So it can run on Android or iOS, as well as actually web and desktop. So it's a really good starting spot for learning mobile. Also, in addition to that, I think that a lot of the things that we learn for Flutter can be applied more broadly. So you might be interested in Android, you might be interested in iOS, or you might be interested in Flutter. But like the architecture that we're using in this project, the good practices of mobile, those all apply across the board to all of these different kinds styles of mobile project. So you can definitely take this and lift it somewhere else, as well as I'm going to try to throw in comparisons to some of the other platforms so that you might know a little bit about Flutter and want to go learn Android. And you can say, oh, Sierra said this is kind of like this in Android. And so it gives you a starting place to look for those kind of solutions. Finally, Flutter, Dart, not really used anywhere else. So this is a really great opportunity to learn them when you're probably not going to be thrown this at work or on a project unless you work in the mobile space already. And everyone is probably at about the same starting spot because it's not a super common language to use unless you're already going out of your way to use it. So what is Flutter versus some of these other platforms? So we have Apple iOS apps written in Swift, Android written in Kotlin, and then some other hybrid cross-platform applications like React Native and Ionic. There's also like Xamarin. There's a whole list of ways to build mobile apps. So when we talk about Swift and Kotlin apps for iOS and Android, we're talking about native mobile applications. And so native just means that it's built to run on a specific operating system. I cannot take an app written for a native Apple app, iOS app, and take it and run it on Android because it's written specifically for that platform. Some of the pros of that means that you're actually touching the operating system. You have access to literally everything that the operating system has to offer you, which is a lot. It's what runs your phone, right? GPS, Bluetooth, all your camera, all of these things are run inside that operating system. And so it gives you a lot of performance. It gives you easier access. It gives you better security compared to React Native and Ionic and other of these cross-hybrid, cross-platform applications. These sit somewhere between Android and Flutter or iOS and Flutter because they're JavaScript frameworks. React Native is obviously based on React. Ionic is, I think, based on Angular. But something special that they do is they still pull native components. So when you look at an Android app or an iOS app, there's a certain feel to those, right? In Android, it's a lot of material design components. There's things that you expect. When you're writing things in React Native and Ionic, they're actually pulling those components right out of the operating system, those things that are shipped with the operating system to make their apps look like what you expect this to look like. And so your React Native on Android will look like an Android app because it's using native text views and native scroll views and these sorts of native components while being able to write all their code in a JavaScript language. Flutter is a UI framework, so it's completely different from these other currently offered hybrid app platforms. So what Flutter does is it pulls a canvas out of your phone, and everything has a canvas, and then it draws on it. And so that opens up a lot of possibilities. For example, you can make your Flutter app look like literally anything. If I want to write an app for an iPhone and I want it to look exactly like an app written for Android, I can do that because it's not touching any native components. It's simply pulling a canvas and it's drawing on it. But it's important to know that that is not like Android or iOS native because it's not touching anything from the native libraries. It's literally completely separate. A lot of plugins have been developed to touch like the camera and Bluetooth, GPS, all these things that are part of the Android or iOS OS. So it doesn't stop you from using those, but you need those bridges that are already written to access those things because the only thing Flutter does is draw on your screen. That's a nice thing about Flutter and compared to some of these others because it means that you can write Flutter apps for any operating system version. particularly when we think about iOS. iOS switches operating systems and drops support for old ones very quickly. Every 2 years or so, they drop an old version. And that puts Swift developers in a really uncomfortable spot where they cannot support those old phones anymore. With Flutter, all of those old phones still have a canvas, and so you can still pull it up and run a Flutter app that you write today on a phone from 5 years ago. So that opens your market up a little bit more. It matters less than in the US market, but around the world, lots of people are using outdated phones. And so this offers you a unique opportunity to support them with modern applications. So let's jump into some of the nitty gritty of Flutter. So Flutter is a framework, and that framework is also written in a language that you probably don't know, which is Dart. Dart started as a web language and then mostly died off and disappeared into the distance until Google was like, yes, Flutter, let's do this. So we need to know a little bit of Dart to jump into this. So Dart is an object-oriented language. It's strongly typed. It's kind of like Java. I'm assuming most people know a little bit of Java. And so we'll look, that's kind of the comparison that we're going to go and look at, is how does this look like Java, so that if you know Java, you can jump in and write some Dart. So here I have 2 examples. On the left, I have my Dart class, and on the right, I have a Java class. So first thing is I wanted to note that like the implement and inheritance structure is exactly like Java. These are completely random. Please don't, I couldn't think of anything to actually extend and implement, so you just got something that came up at the top of the list. So extends object, which is a pretty irrelevant thing to say because everything inherits from object, and implements a list. My class is red because I didn't include those functions that I needed to override. So now that I've mentioned it, we're going to completely ignore this, that one line, and look at some of the other comparisons. So in my classes, I have a couple of the same kind of objects. So in Dart, I have an int. In Java, I have an int, string, and Boolean. So a couple little differences, right? Boolean versus bool. But for the most part, they support a lot of the same types. So we have numbers, strings, Booleans, list, and so on. So now we can look at the function structure. So the function signature is exactly the same between Java and Dart. So we have your return type, your method name, and then your arguments. So we have void public function, and both taken in double. And so those look almost identical. And then finally, my least favorite comparison between the two of these, they both use semicolons. As a primarily Kotlin developer who does not use semicolons, this is very frustrating to me, and I often forget them. As a Java developer, they should be a welcomed addition to your line. So let's talk about a couple of the differences. So one thing you might have noticed is I specifically named some things public and I made some things private to call out these differences. So we notice that on the Java side of things, I have public class, my Java class. And on the Dart side of things, I just have class, my Dart class. And so we see that it no longer has that public access modifier. Similarly, I have a private function on both sides, and it also doesn't include the private access modifier. So Dart does not have the words, the literal syntax, private and public, but instead they use underscores. So something with an underscore is a private function or variable, and something without an underscore is a public class or variable. And so my Dart class is also public, just like public class, my Java class is public. And both my is private Boolean and my private function with those underscores are private functions. So this can be a little confusing. So finally, I just wanted to call attention to list. One difference between Java list and Dart list is that the Dart lists look a lot like JavaScript list. And so you can instantiate them the same way. We just looked at all that JSON notation, which was JavaScript object notation. And so when you make a list in Dart, you're going to make it about the same way. So you'll use list var list equals square brackets, a list of things. And that's how you can write a list directly in Dart. One thing I did not include in this class, but want to make sure that I mentioned, is that this class doesn't take in any variables. Everything is defined here. My integer is 1, my string is my name, is private, is set. And so there aren't any empty variables. Just like in Java, if you have something that needs to be set, you need to make a constructor. And so if I have an unset variable, I need to make a constructor that includes passing that in so that when the class is instantiated, that variable has a value. That value can still be null, but it has to be set in if I don't explicitly set it to equal in my class. So now switching gears, there's a lot of things we have to touch on here to get to the point where you can build an app, is the architecture that we use for mobile applications. Right now, the most popular and widely accepted across the board is an MVVM architecture. So MVVM stands for model, view, view model. And so what you think about these layers is your model is your data objects. So we already talked kind of about how our data objects were going to look when we talked about the JSON. And so I'll have things in my model class or in my model that include things like a member, a resource, a quote, what contact information looks like, what that object links look like. So that is what holds all my data models. When we talk about the view, we're talking about literally the UI. So how does my view look? We'll jump into what this code actually looks like in the next slide, but that view is a bunch of, is built in your widget class. And then finally, a view model is where you hold all your logic. So mobile right now is really important to separate out your logic from your views. And so view models is where you connect your models to your view and do any kind of like manipulation or logic to display it the way that you want. So MVVM. In this particular app, we are going to have a network client and an interactor because we're going to do some network calls to pull from that REST API. And so what will actually happen is we'll have this network client, and that data will be passed into an interactor to kind of like catch that data as it comes back from the network. And then that interactor will pass it up to our view model. And then our view model will manipulate it as it needs to be done and then pass that to our view. And then our model will just describe all those objects that are coming back. So let's jump into what views look like in Flutter. So when we talk about the view in Flutter, we're talking about widgets coming from Android, and iOS is also named, we call everything a view. So in Flutter, that view is actually a widget. And the most important thing to know is that everything on your screen is a widget. Looking at this, my example layout, this line of text is its own widget. This line of text is also its own widget. This number is its own widget. And this star is its own widget. And then the whole screen itself and every layer through that is a widget. So when we are building out our widgets, we will use composition instead of inheritance. When I was first learning Flutter, I found this a really confusing concept to grasp, because I just said Dart is an object-oriented language. We know that inheritance is a key component of object-oriented programming. When we're building widgets, we are no longer in that realm, and so we have to compose our widgets to make our final widget. So what does that mean? When we think about like a text view, it only serves one purpose in Dart, and that is to display a text and style that text and nothing else. So let's say I want to put some padding on it. Padding does not exist in a text widget. And so what I have to do is wrap that component in a different widget to add padding to it. So I take a container, I put my text widget inside of it, and then I add padding to that outside widget. And so that's something that you'll have to like get used to. What what else happens, and we'll look at this in our actual code, is this is a declarative UI. And so what that means is I literally type out my entire UI. This is a really important shift right now happening in mobile across the board. So again, coming back to this is something that you can take and extend to other kinds of mobile platforms. So when we think about Android right now, it's shifting from current Android to Jetpack Compose, where we can write out our declarative UIs. Swift is also switching from its classic Swift to Swift UI, and that is also a declarative UI framework. And so Flutter is already a declarative UI framework where we type out and return explicitly a set of built widgets. I talked about earlier how you can make your Flutter app look like anything that you want, but we don't actually want to do that in most cases. Users are expecting their apps to function and look the way that they're expecting it to function and look, right? I have an iPhone, I know what those components look like, and I expect my apps to function that way. And so the Flutter team gives you a lot of those out of the box. There's material design components and Cupertino components that will automatically make your life a lot easier and give you an app that looks the way that it should look on either device. And so we will be using those in this app. Flutter has a really cool feature, hot reload and hot restart, that won't make you recompile your code, which as someone coming from Android would be super helpful because it's a lot faster. And so all that does is it takes the changes you've made and applies them to your already running app instead of recompiling, rebuilding, reinstalling. Some important widgets that we're going to use are container. So that's like your base container. It has things like padding and margins, and rows and columns. So when we look at this example, if I look at this route icon and route text, those two are stacked on top of each other. So those are going to be a column. So that's my column. And then if I look at all these things together, that's a composition that makes up a row. And so I have a row here, a row here, or a row here. This image view is actually wrapped in a row also. And so the whole thing can become one giant list view. So if I make up a bunch of different items, throw them in a list view, then I can pull out a whole UI. So there are two types of widgets we have to know about beyond just like the types of widgets and how we build that. And that's for your actual class is stateful and stateless widgets, which really is just if your widget is immutable or mutable. Stateless widgets don't have state and therefore they cannot change. They can only be drawn once. Whereas stateful widgets means your widget does have state and that state can be changed and that means you can redraw it over time. So if we look at something like an error screen, that extends the stateless widget, whereas my contact screen, which we'll actually be building out, extends the stateful widget. The difference here is that you see that the stateless widget is immediately built. That override build function has to be called to actually build your UI. Whereas over in my stateful widget, instead I have create state, which returns my contact screen state that has a type made of state, that extends state. So how do I make that widget redraw? Inside your state class, so inside my underscore contact string, it is a private class. I can call set state, and every time that you call set state, it will redraw your UI. So we're going to be doing network, so I just want to give you a tiny background on network. Everything you need to be able to add network calls to this app. So the two keywords that you need to know are future and async, and they're always paired together. So my future just tells me that my response will come in the future, and async tells me that the method might take some time to return. So if you notice here, this feature has a template type of list string, and inside my function, all I do is return that external type, and everything else is done behind the scenes. We will be using RxDart for folks who have done networking or anything async. Rx is a really popular library that extends across languages. So there's Rx Kotlin, there's RxDart, there's Rx Java, there's Rx Android. So but it has a really high learning curve and people don't particularly enjoy learning it. So I'm going to give you exactly the keywords you need to know that we will be using in this project, and hopefully you won't have to use anything else. So behavior subjects and publisher subjects go together. A behavior subject is like if you walk into a room, both emit events is really the key here, and it's how they emit events. So a behavior subject is if you think about walking into a classroom and someone has written the last thing that they told the class right before you walked in. So in that case, you will know the last thing that has happened and then everything that comes afterwards. A publisher subject is like walking in the room and that's not written on the board. And so you only know things that come after. So a behavior subject will emit the last thing and then everything afterwards. And a publisher subject will only emit the things that come afterwards. Streams are going to stream that data up the path to the UI, right? So we have a network, we have an interactor, we have a view model, and then we have a UI. So we need to get that data all the way up. So a stream is just going to stream your data up the path. And because we're having events that might not emit when we expect them to, we need subscriptions, which are just listeners. So those listen to changes in that data. So as those things are emitted, are streamed up the path, a subscription sitting at the top, listening for those changes so that it can react to it. And that is why this is called reactive programming. The way that we'll build out our UIs is using a provider with a stream builder. And what that provider does is it sits there and provides the context needed for that stream to make all the way to the top and then react to it. And we'll see this in the code demos. Just so that you know what this kind of project looks like. We have Android, iOS folders. Those hold your very specific Android and iOS things. Things like permissions. So Android has a lot of permissions and that you have to give access to. API keys, like if you want to add a Google map, you have to add an API key to both the iOS project and the Android project separately. Assets is where we keep all our images and that sorts of things. PubSpec is where we hold all our dependencies and libraries, so anything you want to pull in. And then finally, the lib is where everything lives. So in this case, our lib has an app folder, a data folder, a utils, and a values. App holds our network client and our interactors. UI holds our view models and our views. Data holds all our models, and utils and values are a hodgepodge of things that we'll go over if you need them. So that wraps up the Flutter background. If there are any questions on that, I'm happy to answer before we move on to talking about the next part of this event. Awesome. Okay, so I'm going to send some links in the chat so that you have them. So first, our GitHub. All the slides that we've presented today will be available in our events folder if you need to go and look at those specifically, but it also holds our projects for today. Like I say, during every event, building accessible, welcoming, inclusive events is really important to us. And so we've created a feedback form so that you can tell us what we're doing well and what we're not doing so well so that we can iterate on that. Your contact information is not necessary, but if you want to add your contact information so that we can reach out and find better ways to support you, please feel free. But it's totally anonymous if that makes you feel more comfortable. I also always talk about needing more speakers. Today you saw the Women in Code Cincinnati team in action, but if you have talks you want to give, or more importantly, talks you'd like to hear and you'd like us to find your speaker, a speaker on that topic, we have a speaker form as well. While it asks all those different questions, you can feel free to fill in only the ones that are necessary for your personal request and needs. Okay, that was the rest of my housekeeping. So now, what are we gonna do now? So I promised that this was gonna be really interactive. You guys should all have the skill set now to jump into any of these projects. And so we're gonna start 3 breakout rooms, one for database, one for the Gatsby project, and one for Flutter. In each of these breakout rooms, we will have a live demo of fixing an issue from start to finish, and opening a PR and how to do each one of those steps. And you'll be able to see the code, see where we're talking about all these things that we've explained that we're going to be using, and you'll be able to ask really specific questions. Then after that, you'll be able to go into the issues and pick an issue that you want to work on yourself. And all these rooms will stay open until 1 o'clock. So we'll be here to answer any questions if you get stuck. Let me jump back over here. So I already sent the link to this repo. So a few things about PRs. Issues are under the Issues tab. There are some that depend on others because it's basically impossible to build a project from start to finish without having some kind of dependency on issues. So please make sure that what has already been done matches what needs to be done. When you're ready to start working on an issue, you can comment on that issue and say that you're going to work on it. And then that means to everyone else that they should not be working on that issue. Please don't work on issues simultaneously so that everyone has a chance to work on something. Most importantly, do not merge your branch into our main. We're trying to do this to give you guys Hacktoberfest credit. And in order to do that, we need to tag all your PRs as Hacktoberfest accepted. So open a PR and tag one of the admins. So that's me on the Flutter project, Sandy and Alex on the Gatsby project, and Emily Egan on the database project. And then several weeks from now, you can collect your free t-shirt if you meet the 4 PRs requirement. I do want to mention that even if you don't go to the room, you're more than welcome to open a PR against that project, particularly the database project. One of the key things is building a fun interactive project that has your face and your information in our members tab. So if you're comfortable opening PRs and comfortable with JSON and comfortable doing all that on your own, please feel free to go and open a PR in that project that has your personal information, any resources that you're interested in sharing or quotes. Otherwise, jump into one of the other rooms. If it's your first time opening a PR, the database project might be a really good room to get started in. So what should we do now? So we will be assigning everyone to rooms. And so we'll have to put in the chat which room that you're interested in, and then we will start putting you in those rooms. You're more than welcome to switch rooms between now and 1 o'clock. So you'll exit that room that you're currently in, and we'll drop you back into the main room. And that main room is where Mackenzie is here to help us, as she will start putting people back in whatever rooms you want. So you can either shout out to Mackenzie, she'll be here, or put it in the chat, and she can add you to a new room. So yeah, that's it for us. Now we're ready to break out.